So, piggybacking off of what we just did with transformations, keep in mind that your transformations can tell you where your vertical asymptotes are. So if you remember, this is a log function, so you have vertical asymptotes. How many, see if you remember how many horizontal asymptotes you have. Oh, what's that? What? Oh yeah, you don't have any. So you shouldn't have any horizontal asymptotes with log functions. What these shifts are going to show you, an x minus 2, that is a horizontal shift because it's inside your function. That's going to shift your graph to the right 2, which also means your vertical asymptote is shifted to the right 2. Now, you can use that to help you graph anything, but I just wanted to make sure I went over that before I start going over the natural log function. Here we have your natural log function. Your natural log function, that is when you have an e to the x. Okay? Sorry, not e to the x. That's your exponential function, natural exponential function. A natural log function is when you end up with a natural log of x. So you'd have the equation f of x equals the natural log of x. Okay, this is your natural log function. So here you have y equals natural log of x, and a natural log of x, that is the same as saying the log base e of x. And what they do is they just simplify this down since it's a natural log. And if you can figure out why this is ln instead of nl, I will give you plus 5 bonus points. Actually, heck with that. I'll give you plus 10 because I'm such a nice guy. So if you can figure out why they call this, it's written as ln and not nl for natural log, bring that into me Monday, and I will give you 10 points bonus if you can explain that to me. So what we have here is your function f of x is log base e of x, can be written as, and you'll see it as ln of x. This is your natural log function. It is, still has a, here's a picture of it, still has a vertical asymptote at 0, goes through 1, 0, but your points are 1, or e comma 1, 1 over e comma negative 1. It is the reciprocal, or sorry, the inverse of f of x equals e to the x, reflected over this line. So if we want to evaluate this function, f of x equals a natural log of x plus 1, we're going to evaluate natural log of 73.25 plus 1. So let's go to your calculator. Your natural log button is right here next to the 4, ln. So that's 73.25. Now notice you have parentheses. If you put plus 1 like this, that will not evaluate it correctly. You need to make sure you close off the 73.25 with parentheses and then put plus 1 and evaluate that, and you get a 5.2939. So 5.2939, and that would be your solution. So let's try to find the natural log of 0.4 plus 1. So natural log of 0.4 plus 1. You plug that into your calculator, and you get natural log 0.4 plus 1, 0.0837. So if we want to add that plus 1, if we would just find the natural log of 0.4, you get a negative number. Weird, because that's kind of like a fraction, 0.4 is kind of like a fraction. So maybe there's some kind of, I don't know, some kind of resemblance or some kind of relationship between if you find the natural log of a fraction and negative values. I don't know, maybe, what if we try like 0.26? Weird. Kind of weird. So, back to the problem at hand though. You're going to have a 0.0837. So, I like to put these little approximation signs, which you should put if you are actually, anytime you're rounding something, you should really do that. Now let's find the natural log of negative 2 plus 1. So natural log, negative 2, in parentheses, plus 1. OMG. Non-real answer? What are you talking about? What are you talking about? Well, back in the days of trying to evaluate a log function, like way back in the days, oh, I don't know, maybe back here, example 1-ish. Dun, 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 dun. Oh, example 2. When we found if we put a negative number in after our log, could we find an actual answer? No, because if you take this base, you're going to have to figure out what this base to what power can equal a negative number. Well, on this case, for example 7, if you have a negative 2, you're trying to find the natural log of negative 2 plus 1. Well, natural log of negative 2, if you just set this equal to y, this is really y equals log base e of negative 2. So if this 2 comes up underneath the y, and you get e to the power of y is equal to, this cancels, negative 2, well, e to any power is never going to equal a negative value. So what you're going to say here is a no solution. Not 0, no solution. Alright, and then you can plug in a 2 plus radical 3, and you end up just getting, let's see, let's go to natural log of 2 plus second square root 3. Whoops, don't want the parenthesis under there. Make sure you put the parenthesis on the outside. Parenthesis. And you get a 1.3170. So this equals 1.3170. So that is how you evaluate a natural log function. Just remember, anything after the natural log cannot be negative.